All right, today we're going to learn about how we can classify different systems of equations, and we're going to be able to do it without even graphing. So we have to understand a few concepts, remembering what systems of equations are, remember the solutions from when we graph them, and everything we did in the previous lessons so we can work with the current one. So we have to think about what is a system of equations, and remember what is the solution to a system of equations, because if we can remember that concept, we will be able to apply it to looking at a system of equations and then determining if that system has 0 solutions, 1 solution, or infinitely many solutions. So first let's go back into the concept of what is a solution. Okay, so remember the solution is the ordered pair that all the equations have in common. Okay, so it was the one ordered pair that they all have in common. And from the graphing lesson, we talked about, if you look at the graph, it's where the two graphs meet or where the two graphs intersect. All right, so that's going to help us understanding what does it mean to have 0 solutions, 1 solution, or infinite solutions. All right, so let's talk about what does it mean if there are 0 solutions, if there are no solutions. Okay, so 0 solutions, no solutions. What does that mean? Based off of this definition, well, if they have no solutions, doesn't that mean they don't even meet? Okay, so 0 solutions means they don't meet. They don't intersect, they don't cross, and that would mean something else entirely. So this goes back to a previous vocabulary term. If they are not intersecting, they must be parallel. Okay, so if they're not intersecting, they must be parallel to one another. Something that looks like this. There's one line, there's the other line, they're parallel, they are not intersecting, and if they are not intersecting, they will have no solutions. But then we got to think more. Well, what does that mean? Do you remember what we know about parallel lines? So what do we know about parallel lines? They have the same slope. Okay, so if they're two different lines, but they have the same slope, they are parallel. Okay, so they're two different lines. They have the same slope. They are parallel. And if they're parallel, they don't intersect. And if they don't intersect, they have no solutions. Okay, so how can we tell by looking at a system of equations if a line is parallel? Different lines, parallel, same slope. They don't intersect, 0 solutions. So what does it mean to have 1 solution? Okay. What does it mean to have 1 solution? Well, remember, what is the definition of a solution to a system of equations? It's where the graphs meet. That means the graphs cross. Okay, so that means the graphs cross. They cross at some point. Okay, so they cross at some point. And what does that mean in terms of the lines? Okay, that means they're not parallel. Doesn't mean they're perpendicular per se, it just means they're not parallel. Okay, so just because they're not something doesn't mean they are another thing. They're just not parallel. And what does that mean? If they're not parallel, that means they must have a different slope. Okay, so it must mean they don't have the same slope. They must have different slopes from one another. Okay, so two different lines, two different slopes. No matter how different they are, if the slopes are different, they're going to cross at some point. Okay, so they could cross, at some point eventually in the future. So even two lines that look like this, right? Two lines that look like that, they are eventually going to cross. Okay, they have different slopes. They're eventually going to cross. They're going to cross at one particular point. They're going to cross where the graphs cross is the solution to the system. Okay, so that's what it means to have 1 solution. Now, remember there was a third choice, though. There could be infinite solutions. How would that look? So there could be infinite solutions. Now, what does that mean? That means we're actually looking at two different equations but they're really the same. That means we're looking at the same line. All right, so two different equations of the same line. Okay, so the same line overlaps. And that's when you have infinite solution, a line that overlaps itself. Okay, so they're not parallel. They're not two different lines. They're actually the same line that overlaps. So if we have one line like this, and then I end up graphing a second equation, and it turns out that the second equation makes the same line, that's infinite solutions. Okay, that means they're going to go on, continue forever. Okay, so that means they have two different looking equations. Okay, so the equations look different, but they're actually the same. The equations look different, but really they're the same. Okay, and if they're the same equation, that means they have the same slope and the same y-intercept. Okay, so they have the same slope, same y-intercept. Now remember, we're going to be able to find all of this information out without graphing. All we have to do is remember the concepts. Okay, the concept. Solution of a system of equations is where the graphs meet. If the graphs are parallel, two different lines, but they're parallel, they have no intersection, that is zero solutions. And that's a vocab term that's called an inconsistent system. Okay, if the two lines do cross at any point, doesn't matter where, okay, if they cross at some point, that means they have different slopes. No matter how different the slopes might be, they're going to cross. They're not parallel, they're crossing at some point. That's one solution. That is called an independent system. And then there's a possibility of a third, which is called an infinite solutions. So if we have infinite solutions, that means we're looking at a line that's overlapping itself. The equations might look different, but they're actually the same. That means they have the same slope, the same y-intercept, and that's infinite solutions. That vocabulary term is called a dependent system. Okay, so those are just the vocab terms for those types of systems. But for our test, we're going to ask questions. Are they infinite solutions, one solution, or zero solutions? And we're going to be able to determine this without even graphing. Okay, so how are we going to do that? How are we going to do that? So let's go back to the question. Now that we have the concept down, not that question, another question. So now that we have the concept down, we can go into the question we began with. Okay, so we have three different systems of equations that are listed here, and without graphing them, we're going to determine if the system has zero solutions, parallel, not crossing, one solution, different slopes, definitely crossing, or infinitely many solutions, two different equations, but actually they are the same. All right, so let's look at the first system. In the first system, we see two different equations. They look different, right? But we're not going to graph them this time. All right, so we have 2x plus 3y equals 9, and y equals 2/3 x plus 3. Now, the key ingredient to all three systems is one thing in particular. If you notice, there was a theme that we were comparing in all three systems. And that theme is to compare the slopes. So we're going to look to compare the slope of these two lines. Without graphing, can we compare the slope? So the first thing we can do is look at the top equation. Well, let that be the second thing we can do, because look at the bottom equation. Seriously, what's the slope of this bottom equation? Clearly, the slope of this equation here is 2/3. Okay, so it's rising 2 to the right 3. So up 2 to the right 3, that's this slope. Okay, so we can tell because it's clearly in slope-intercept form. But what about that top equation? How can we tell what the slope of that top equation is? There are two different ways. First, I'm going to do the hard way. The hard way is to make this equation into slope-intercept form. If we make this equation into slope-intercept form, we'll be able to tell everything we need about it. All right, so we have to get y by itself. Now, right now, y is not by itself, so we're going to have to subtract 2x on both sides. And when we subtract 2x on both sides, we'll have 3y equals negative 2x plus 9. And again, you can see the y is not by itself. Okay, so we have to then divide everything by 3. And now we can see what this equation is going to be in slope-intercept form. So now negative 2 divided by 3, well, that's just negative 2/3. And then there's x. And then 9 divided by 3 is 3. So here is, in fact, that top equation. Now remember, the top equation started like this. But when we manipulate it and we make it look like slope-intercept form, it looks like this. Okay, so how does that compare with the second equation? Well, remember what we're trying to do. Without graphing, we are just comparing the slope. The slope of the second equation was easy to see. The slope of the first equation, not as easy to see unless you know of the shortcut from a previous lesson. But the slope of the second equation is clearly negative 2/3. So we can see here that this slope is negative 2/3. All right, and that was the top equation, right? So this top equation, the slope is negative 2/3. All right, so now we're ready to finally draw our conclusion based on the notes that we took. Okay, remember the notes we just took. We just took them. If there's 0 solutions, that means they don't intersect. That means they have the same slope. If there's 1 solution, that means they do intersect. That means they have a different slope. And if they're infinite solutions, they have the same slope and the same y-intercept, same equation. So what have we noticed about this system? Clearly these slopes are different. And if the slopes are different, well then we have what's called an independent system. And that means we have 1 solution. Okay, so that's how we can tell without graphing, we didn't graph a thing, that they are going to cross. Okay, so these lines will eventually cross. How do we know where they'll cross? Well, we could graph it. Okay, we could graph it, or we could pay attention to some things that are happening right in front of our face. It'd be cool if you could tell me in class, hey, where do those lines cross? Because you can tell by looking at the equation. But either way, there is 1 solution. Okay, so that's that top system. So now let's take a look at the second system. Okay, so now we have another system of equations, and we're going to determine without graphing, do they have 1 solution, 0 solutions, or infinitely many solutions? All right, so we can look at the top equation. And remember what we're trying to do. We're trying to compare the slope. So we're going to compare the slopes. What do we know about the slope of that top equation? Clearly, this slope of the top equation is 2/3. Easy to see, done and done. What about the second equation? Again, it could be easy to see if you know what you're doing, if you remember a shortcut from a previous lesson, but we have to find the slope of this equation. So one of the ways we can do it is to put it into slope-intercept form. Okay, make it look like y equals mx plus b. And just like before, we're going to have to get y by itself. So here we can undo 2x from both sides. And we'll be left with a negative 3y. Got to be careful. And then negative 2x, positive 9. And still, y is not by itself. So now we're going to divide by negative 3. And then we can see we're going to have y by itself finally. Then we have negative 2 divided by negative 3. Negative divided by negative is positive, so positive 2/3. And then positive 9 divided by negative 3 is negative 3. Okay, so now we have our second equation. All right, so we've rewritten our second equation to make it look like slope-intercept form. And now we can clearly see the slope. Hey, this slope is 2/3. Okay, so we have the second slope is 2/3. Now what does this mean for the question? Remember the question. 0 solutions, 1 solution, infinitely many solutions. Go back to the notes. So if it's 0 solution, they're parallel, they have the same slope. If there's 1 solution, they cross, they have different slopes. If it's infinite solutions, they're the same line, they have the same slope and the same y-intercept. What do we know? We currently know that these two lines have the same slope. That means they either is 0 solutions, that they're parallel, or that's infinite solutions, they're actually the same line. Same slope, same y-intercept. Since the slopes are the same, now we have to look at the y-intercept. Okay? So if the slopes are the same, let's look at the y-intercept. Okay, so now we're going to compare the y-intercepts. Look at this top equation. What is the y-intercept of this top equation? Positive 3. Okay, so the y-intercept in that top equation is positive 3. Look at the second equation. Remember, we had to rewrite it to look like this. Okay, so we took that second equation, we rewrote it. What is the y-intercept of the second equation? Negative 3. So are the y-intercepts the same? No. Okay, so the slopes are the same. Compare the y-intercepts. They are not the same. They are different. So what does that mean? That means these two lines are parallel. So these two lines are parallel. They have the same slope. They have different y-intercepts. They are parallel lines. And of course, from the notes, parallel lines have 0 solutions. Okay, so this particular system has 0 solutions. And we can tell without even graphing. Okay, so this was the original system. We had to look back. We could tell without graphing, 0 solutions. So now let's apply everything we've learned to the third system. So what's going to happen in that third system? Well, remember what we're trying to do. We need to compare the slopes. If the slopes are different, we're done. 1 solution. If the slopes are the same, we have to continue looking. All right, so let's look at this top equation. We need to find the slope. Okay, again, if you remember the shortcut, you could know the slope just like that. But I'm not going to tell you. We have to compare the slopes. So this slope, if you can't see it right away, we have to make it look like y equals mx plus b. So we're going to get y by itself. That means we're going to undo 4x on both sides. And then we'll divide everything by positive 6. All right, so we're undoing, and then we're dividing. Now, what's going to happen? We're going to have y equals. Now, we have negative 4 divided by positive 6. That's negative 4/6. Negative 4/6 can be simplified. Both can be divided by 2. So we have negative 2/3 x. And then we have 18 over 6, which is 3. So this is our first equation. Now remember, our first equation looks like this, and we rewrote it to make it look like this. This is our first equation. So what do we know? We now know the slope is negative 2/3. Just in case we have to compare the y-intercept, it's clear to see the y-intercept is 3. All right, so now we've done the first equation. Let's take a look at the second equation. So the second equation is y equals negative 2/3 x plus 3. Doesn't that look familiar? Holy cow, it's the same equation. So this is the same equation. No way. That means this equation has a slope of negative 2/3 and a y-intercept of 3. So they're actually the same line. Now take a look at the original equations. This equation is the same as this equation. That can't be. Oh, but it can be because we just proved it. Okay, so these equations may look different. They're actually the same. So we compared the slope. Compare the slope, nothing. They're the same exact line. So they are the same line. Now going back to the notes, what does that mean for the system? They're the same line that overlaps. The equations look different, but they're actually the same. Same slope, same y-intercept. This has infinite solutions. It's called a dependent system. So this has infinite solutions. So just like we had with equations, you know, sometimes there's no solutions, sometimes there's infinite solutions. Same thing with systems of equations. Sometimes there's no solutions, sometimes there's infinite solutions. All right, so we're going to be able to tell all that information without even graphing, okay, by comparing slopes, comparing y-intercepts. We can now tell if a system has 0 solutions, 1 solution, or infinitely many solutions.